So this is the second of 4 videos that we're going to watch on chemical reactions and predicting the products of chemical reactions in grade 10 science. And so I'm hoping that you completed your worksheet on synthesis reactions and that you're ready to go. So the second type of reaction we're going to look at is what's called a decomposition reaction. So I'm hoping when you think of the word decompose or decomposition that you're thinking about things breaking down. And that's pretty much what's happening in a decomposition reaction. So let's take a look at it. So one way that I recognize a decomposition reaction is because I'm always starting with a compound and just a single compound. There's nothing else that AB is reacting with, so really the only thing that it can do is simply break apart. And so we see an element, here we have an element, no we don't, we have a compound that breaks down into its elements. Now, there's a caveat to this, which is, in grade 10, we're simply only going to look at the case where compound breaks down into its elements, but please know that there are decomposition reactions where we take a compound and break it down into 2 or more simpler substances, some of which can be compounds or elements. But this year we're going to keep it simple. So let's take a look at a few examples. So this is as good a time as any to remind you about the diatomic molecules. And you'll remember Hofbrinkel. We talked about Hofbrinkel in one of our earlier videos. So remember that Hofbrinkel is, I forgot my N in here, a trick to help us remember the diatomic elements. So those are molecules that don't exist in element as an individual atom. So for instance, hydrogen, we're never going to see a hydrogen atom. It's always going to be H2. Oxygen is always going to be O2. Fluorine is always going to be F2, and so on and so forth. Right, and so, oops, I forgot nitrogen. I'm going to put nitrogen over here. Right, so Hofbrinkel, and that's going to be important for us to remember as we're predicting products in these chemical reactions. So let's take a look. So I'm going to go through a few examples with you. So in this first example here, I have HGO, and so on the periodic table, mercury and oxygen are combining to form this mercury oxide. And so all I need to do in this case is simply, I usually start by just saying, okay, well, I know that since there is a single reactant, which is a compound, that's my cue that this is a decomposition reaction. And so all I need to do is simply take my Hg and take my O and write them as separately. But now I'm going to, again, remember Hofbrinkel. And that's going to remind me that oxygen is diatomic and I need to put a 2 there. Okay, so what I'd like for you to do right now is to try these 2 next examples, pause the video, and then we'll take them up in a minute. Okay, so hopefully you've attempted these next 2 questions. I'm going to go ahead and give them a go. So again, I can see that this is a decomposition reaction because I have a single compound, a single reactant, and that's my cue around that. And so what I'm going to do now is I'm simply going to separate these elements. So I have potassium and I have oxygen. And potassium is not diatomic. It's not part of this Hofbrinkel business. So it just stays as K. But oxygen is, and so I'm just going to write my 2 there. Okay. Now people often say, well, why is this 2? What is that? What the heck is that about? Why is that there? Well, you'll remember that, potassium, this is just on the side here, folks, not part of this response. Potassium has a +1 charge and oxygen has a -2 charge. So to get the formula for potassium oxide, I needed to have crossed down that charge on oxygen and hence that 2 there. But that has nothing to do with what happens to these elements when they separate. In fact, what I need to do to compensate for that 2 there is I need to properly balance this reaction, right? And so, I'm going to go ahead and do that just so that you can see what I'm talking about. And so this 2 that is here, I just need to go ahead and balance. But I have 2 oxygens on my product side, which means I need to have a 2 in front of my potassium oxide. but then the 2 times 2 gives me 4 potassiums, and now this thing is balanced, and now I don't need to worry about where atoms went to. Okay, let's look at the next example. So in the next example, I have sodium, Na, and I have Br, bromine. But then I go ahead and I see, oh, well, you know, bromine is right here, so I need to make sure that it is written as a diatomic element. There we go, Br2. And if I was so inclined, I could even take the extra step and see, well, if I have 2 Brs on the product side, I need to have 2 Brs on my reactant side. But that also changes the number of sodiums, so I'm going to put a 2 right there. And now everything is balanced. Okay, so that is the second video on binary compounds, looking at decomposition reactions. And so what I'd like you to do now is go back to your, I'd like you to go back and complete the worksheet on decomposition reactions, and make sure you're checking those answer keys to see that you're on the right track and reaching out if you need any extra assistance.